To sum up this particular chapter, what we have done and what we have discussed in this, first we started off by understanding what is a differential equation, correct? So how did we define this? If it is an algebraic equation with a derivative as one of the terms, that is basically a differential equation, correct? Then moving on, we discussed the two major parts of a differential equation, that is order and degree, right? So order talks about the highest derivative, right? And the degree is the power of the highest derivative. That's the degree, right? Once you know what is the order and what is the degree, the next thing was how are we going to form a differential equation under different scenarios and circumstances, correct? Suppose if you want to frame a differential equation, then how are we going to go about it? That was the next topic what we discussed, especially for family of curves, like for circle, ellipse, parabola, whatever it might be, right? Then if you have a differential equation, how are we going to solve, right? That's where we have three. That is, first one is the variable separable method, second one is the homogeneous method, third one is the linear differential equation solving method, right? Now all the three are very unique. Variable separable method, we are going to use this when the variables in the differential equation can be separated. Then we use variable separable method, correct? And then once you separate the variable, you separate the dx and dy, integrate it separately and get the answer, correct? This is the variable separable method. Next is homogeneous method, second one. In homogeneous method, how did we define it? So if a function can be represented as lambda power n into f of x comma y. That means if you substitute the variable y as lambda into y and x as lambda into x, then even if you substitute that in the function, if the function can be represented as lambda power n into f of x comma y, then that is a homogeneous function, right? Now, in almost all the homogeneous function problems, we converted the homogeneous into a variable separable method, and then we integrated and got the answer, correct? This is how we do the homogeneous method. Now, the last one is the linear differential equation. See, in the linear differential equation, the first thing, we have to have it in a particular form. That is, it should be dy by dx plus p into y is equal to q, where p and q are constants. Either this method, as in this form you can say, or dx by dy plus p into x is equal to q. Either of this form. Now, once you have it in the standard form, then you figure out the integrating factor, right? Which is e to the power of integral of p dx or e to the power of integral of p dy, depending on the standard form what we have. Once you find the integrating factor, then we do y into integrating factor is equal to integral of q into integrating factor into dx plus c or dy into c, whatever it is, right? So this is basically the final equation for the linear differential equation, isn't it? So far, whatever we have discussed is all about first order differential equation, if you look at it, right? So the chapter of differential equation is now completed.